Hello, today we'll be discussing volume by rotation, and this paper slide is by Julia Seffler, Nadia Johnson, and Ashley Zhang. Now you may ask, what is volume by rotation? And this is simply finding the volume of a solid by rotating a set integral or radius around an axis or line. So here we have a set graph, and by rotating this around the x-axis, we form a three-dimensional solid. And today we'll learn how to find the volume of this solid. So let's flash back. Before, we learned to find the area of a circle, we use the formula pi r squared. Now let's look at rotation. By rotating it around a set line, you are essentially forming many circles. So to find the volume of this, wouldn't you just find the area of all these circles? And this is called the disk method. So we'll use the same formula as our circle, pi r squared. So here, r squared would be the integral of the graph, ln x, which forms all these little radiuses. So to write our volume, we'd put pi, integral from a to b, of ln of x squared dx. And this gives us the volume of this solid. So now let's do an example problem. Find the volume of the solid formed by rotating the area of the graph y equals negative x squared plus 2 and y equals 0 around the x-axis. So first you would draw out your problem, and I went ahead and drew the graphs of y equals 0 and y equals negative x squared plus 2. So next we would find the intersects of the graphs y equals 0 and y equals negative x squared plus 2. So let's simplify it out. We would make negative x squared plus 2 equal to 0. Subtract the 2. Negative x squared equals negative 2. Then we can get out the negative sign, divide by negative 1. X squared equals 2. So then we take the square root of both sides. We find that x equals plus or minus the square root of 2. So that would represent our two intersects. So I'll write that here. Negative square root of 2 and the square root of 2. And these are the x values. Alright, so let's write our integral. Finding the integral between negative square root of 2 and the square root of 2 of our radius, which in this case would be negative x squared plus 2. So I'm going to put that in. Negative x squared plus 2 squared dx. And then we have to put the pi out front. So we have pi, our integral, which is r negative x squared plus 2 squared dx. So pi r squared. And this would give us the volume of this solid. Alright. So another case would be where when you rotated it, it forms a hole in the middle of the two graphs. So in this case, we would use the formula pi, the integral from a to b of the big radius minus the small radius, little r squared dx. So we take the graph of the top, r squared, and subtract the graph underneath, little r squared, which in this case is y equals x squared over 4. to find the volume of the graph in between rotated around the x-axis. So here I wrote out the integral. Pi times the integral from 0 to 4, which is where the two graphs intersect, of x squared, which is the top, the big R, squared, minus the little r, x squared over 4 squared. And you plug that into your calculator and you get approximately 26.808. So here's a visual of the problem that just went on. As you can see, when you rotated it, it has a big hole in the middle of it, which accounts for a lot of volume lost. So when you divide it out, it looks like a lot of little washers. And this is called the washer method because the circles have holes in them that resemble a washer. So another case, we'd find the volume of the area between the graphs y equals e to the x, y equals 0, and y equals e squared, and rotate that around the line y equals -2. Now what changed here is the axis we are rotating it around. We're not rotating around the y-axis or x-axis. We're rotating it around a line. So in this case, we'd have to add in the line, add in the 2, which is the length of the line, to account for the extra space between the graph and the line you were rotating it around. So this is the space between the line and the x-axis, which you would originally rotate around. So to form this, we do pi times the integral from 0 to 2, which are the intersects between y equals e to the x and y equals e squared. And we do the big R, e squared, plus 2 to account for this extra space, squared, minus little r, e to the x squared, plus 2 squared dx. And this is approximately 115.953. So in conclusion, to calculate the volume of rotation of an area by using the formula pi, the integral of a to b, from big R squared minus r squared dx. And big R is the distance from the axis of rotation to the furthest edge of the area being rotated. And little r is the distance from the axis of rotation to the nearest edge of the area being rotated. And all of this is an explanation of the washer method. And in the disk method, we'll calculate the simpler rotations without a hole using the formula pi from a to b of big R squared dx. Since there's no hole, we don't need the little r squared.